All right, so here I have this function. I'm being asked to graph it and then find a couple of limits. All right, so let's investigate this. This looks very similar to that graph. So I'm going to factor an x off to the side, and then I have this. All right, so it's still multiplied. I'm just kind of moving them around. So I know that this is that graph. So what does that graph do for me? This gives me a 1 or a negative 1, depending on if I'm bigger than 0 or less than 0, right? So I'm going to encourage you to make up a piecewise defined function. You're budding mathematicians. So I'm going to have if x's are less than 0, I'm going to have if x's are bigger than 0, since I know x's can't be 0. So if x's are bigger than 0, then this gives me the number 1. And then I'd have this x carrying along. If x's are smaller than 0, then this gives me a negative 1, and this x carries along. So I'm just going to clean it up. So this is negative x if x's are less than 0, and it's x's if x's are bigger than 0. So I know what y equal negative x looks like. Y equal negative x looks like this. And what part of that graph do I want? Less than 0. And then I know that what y equal x looks like this. And if x's are bigger than 0 is this. So putting together my solution graph, I get that. So that's the graph. All right, so let's go find the two limits. So the limit as x goes towards 0 from the negative side of this function is 0. And as x's go to the 0 from the positive side, it's 0. All right. Not too bad, right? Okay, so let's try another one. Try to keep, well, I gotta make room for it. Okay, here we go. So I see x minus 2. So let's rewrite this as x plus 2 times x minus 2, and keep this x minus 2 down here like this. So this is in parentheses because this is that graph, right? And it changes at 2. So if I was just to graph this one, right, just to make sure you know what I'm talking about, it's this, right? Okay. So what I'm going to encourage you to do is make up a piecewise defined function, break it up for x is less than 2 and bigger than 2. All right. So x's are less than 2. If x's are less than 2, this graph here is giving me a negative 1. So I'm going to carry along this x plus 2. If x's are bigger than 2, I'm up here. So this graph, that graph there is giving me a positive 1. And that's going to be multiplied times x plus 2. So let me fix that. So I have, whoops, that over here. Okay. There we go. Negative x minus 2 if x's are smaller than 2, and x plus 2 if x's are bigger than 2. So be really careful. So if I'm going to graph y equal negative x minus 2, so y-intercept negative 2, negative slope looks like this, right? So what part of that graph do I want? When x's are smaller than 2, so I'm going to be picking up this part of the graph, and then the y value that's associated would be negative 4, right? So I'm going to make my red solution graph over here. So it looks like here's negative 2, there would be 2, open hole, negative 4. All right, so now let's go graph the other one, y equal x plus 2. So x plus 2, line crosses at 2. And what part of that graph do I want? I want when x's are bigger than 2. So 2 bigger than 2, and this would give me the y value of 4. So at 2, y value of 4, not at all connected, correct? Make sure you're careful to make two separate graphs. All right, now I'm going to answer the two limit questions. So limit as x goes towards 2 from the negative side, and limit as x goes towards 2 from the positive side. So 2 from the negative side, coming in towards 2, I'm going to -4. 2 from the positive side, jump on the graph, I'm going to 4. Very different.